Hello everyone, this is the lecture video of Calculus 3 Math 2533, section 12.3, part 2, second part, and second part of section 12.3. So this is where we left off in the part 1, right? That was example 2, which is supposed to be a homework problem, but you have my lecture note copy, which is the answer all the way. But what you should have learned from this example is that even when your domain can be easily expressed as type 1 and type 2, sometimes, not always, sometimes one approach is much harder than the other approach. First example, both ways were easy. Okay? Now, let's do a few more examples. Here. All right. Now, example 3 is opposite problem. They gave you iterated integral and asked you to find, sketch the region of integration and change the order of iteration. Okay? Change the order of iterated integral after you find out the region of integration. Okay? So, the given integral I, I'm going to call it I, is from 0 to 2 minus square root of 4 minus x squared to positive 4 minus x squared f of xy dy dx. Okay? So domain of integral. So d, as it is given, what is it? X runs from 0 to 2, right? X runs from 0 to 2. For given x, y runs from here to here. Right? Now, what is this? Y equals negative 4 minus x squared. If you square, you get this, which is x squared plus y squared equals 4. It's a circle with radius 2, right? Y equals this one, also same thing. So you get this circle. So this is upper semicircle because positive, lower semicircle. So x runs from 0 to 2, right? From lower semicircle with radius 2 to upper semicircle. So this is a right half circle of radius 2 centered at the origin, right? This is the way we just analyze, right? Well, we can write this one as type 2. What is it? Y runs from negative 2 to 2. We're given y. We're given y, we run it this way. This is x equals 0. This is h1 of y. And this is, if you solve this one for x, 4 minus y squared or negative 4 minus y squared. This is a right half circle. This is left semicircle. So we have to choose this one, not this one. Right? So this is your h of y, h2 of y. So for given y, x runs from 0 to this. So once you analyze the domain as type 2, you can just translate into iterated integral. This can be written as y runs from -2 and 2, right? Okay. And then x runs from 0 to or minus y squared of f of x. Okay? That would be the way to convert from type 1 to type 2. All right. So, another conversion of the problem. Okay, now example 4. Evaluate this integral. X runs from 0 to 1, y runs from x squared to 1, sine of y cubed dy dx. All right. When you try to integrate with respect to y, x cubed is just a constant. Y cubed, y is the only variable. So you basically have to integrate this without the derivative inside 3y squared, at least y squared. We can't integrate this. We can't do that. All right? So we want to analyze the domain, just like this, and switch the order. So this is domain of double integral of this thing. Now, your domain here is, it's given this way. X runs from 0 to 1, right? We're given x squared to 1 for y. X is 0 to 1. Y runs from y equals x squared. Right? Y equals x squared to y equals 1. Y equals 1. This is the way we analyzed, right? X runs from 0 to 1. We're given x. Y equally runs from x squared to y. All right. Let's write this one in type 2. Also, y runs from 0 to 1. For given y, y runs x equals 0, right? To this one can be written as x equals square root of y. All right, so for x positive one, so we don't need negative square root of y. Okay, so now x runs from 0 to square root of y. Okay, so the type 2. So your double integral can be written as y runs from 0 to 1. For given y, x runs from 0 to square root of y, x cubed sine of y cubed. Okay? And let's see if this gives us better, easier integral. So, for x, this is just a constant. Sine of y cubed. 1/4 x to the 4th. X runs from 0 to square root of y. Okay? Square root of y to the 4th is y squared. Y squared minus 0. So you have 1/4 y squared sine of y cubed dy. Now you have y squared. Constant multiple of derivative inside function y cubed. Right? So if you use u equals y cubed, y squared dy. So y squared dy equals 1/3 of du.
right? Well, anyway, 1/4, 1/3, it would have been 1/3 of du sine minus cosine of y cubed. 0 to 1.
Okay? You can use, substitution if you want.
Then you have to change this value accordingly. Well, it's still 0 to 1. Anyway, so it's minus 1/12. Cosine of 1 minus cosine of 0. Okay? Now, cosine of 1 is cosine of 0 equals 1. Take in minus inside. This will be 1 minus cosine of 1. This is cosine 1 is cosine 1 radian. Okay? So it's less than 1. This is positive number as we expected. Okay. Now, the properties of double integral. Properties of double integral. Properties double integral. First, what do you have? Double integral can be split over addition inside, just like the definite integral in calculus 1 and 2 you learned. Okay? Double integral, just like a definite integral, can be split over addition. And second,
By the way, let me check recording.
all right, and then constant multiple can be taken out of the double integral. This is exactly the same
As the properties of definite integral.
And third, if f of xy is greater than for all xy in the domain, all right, then double integral of smaller function is smaller than the double integral of larger function, just like
One variable definite integral.
Or if D, domain D, is a union of two domains where, I'm not going to write, where, so basically the domain D can be split, D1 and D2, and they share only the boundary curve, okay, not a region. Okay, they do not overlap except for the boundary curve. Then double integral of this one can be calculated. Double integral over D1 plus double integral over D2. Okay, I didn't write all the details here. Now, 4. Double integral of constant function 1. So that means your graph is constant, so plane. You always have a height 1 everywhere, right? That's what it says. So double integral is the volume of the region bounded above by this constant function 1, bounded above the xy plane, right? Vertical walls, side walls. So this is a general cylinder, right? the volume of this region, cylinder, is the area of the domain times height. But your height is always 1, right? So this double integral of constant function 1 give you the area of the domain. Okay? The area of the domain. Oh, man. Sorry about the interruption. Okay, so finally, actually that's the extension of this, actually. If your f of xy is always greater than or equal to some minimum value, or less than or equal to m for all xy in the domain, then double integral of xy over d is less than capital M and area of d. Lowercase m, area of d. Okay? You know, this is actually, I can make a comment on this one. It's not really much. This is direct consequence of this. So, if you apply this third property to this one, then what do you have? Double integral of a smaller function is less than or equal to double integral of a larger function, right? And if you apply that theorem to this one, which is again smaller than the larger function. Now, what is this? This is just nothing but constant multiple. Constant multiple can be taken out. So 1 dA. 1 dA, just learned it, that is area of d. Right? Likewise, m taken out 1. Also, this is capital M times area of d. That's how you got it. Okay. Now, final example of this section. Example 5. Use property 6, I'm not going to write anything, to estimate the integral of this one, where this d is the disk, radius 1/2. So the disk with center at the origin, 1/2 square, so 1/4. Right? Radius 1/2 means 1/2 square, 1/4. This is it, right? This is the domain. 1/2, 1/2, -1/2, -1. This region. All right? We're not going to calculate this one. We want to just estimate using this property. Now, because of this, obviously, for all x and y in D, it is always, obviously, square plus square is greater than or equal to 0. Let's say it's 1/4. Therefore, e to the 0, e to the 1/4, which is 1, right? Always. This is your lowercase m, this is your uppercase m. So this double integral is, according to this, upper bound value times area of d. What is area of d? Pi r squared, pi 1/2 squared. Pi over 4, right? This is pi over 4 times e to the 1/4. Okay. Okay, so this is 1 times area of D, which is pi over 4. Okay? So you have pi over between this number and pi over 4. Okay? Well, that's the end of section 12.3. Okay, well, you're supposed to do one more section, 12.4, in this week, the week of March 30th. Okay? Well, no. Actually, on Monday and Tuesday. All right? And then you're going to do 12.5 and 6, later part of the week. Okay? All right. Thank you. And I'll see you next time.